Hi there. Hey, let's take a few minutes and talk about small hole gauges and telescopic gauges, how to use them, and find out how accurate they are compared to other methods maybe. So what are we talking about here? Well, telescopic gauge set, small hole gauge set. Small hole gauges, size range 125 thousandths of an inch up to a half inch. This set here is sold by SPI, and it was Japanese made, high quality. The way it works, you turn the screw here and it moves a tapered end here, which causes the two halves to move apart from one another, and you can measure the bore by taking this out and measuring it with your micrometer. The telescopic gauges, I have two different sets here. Again, this is SPI one, and this is made in Japan. This other set here I had purchased for the larger telescopic gauge. This is Chinese knockoff, and I don't really care for these as much. They did the job. I was measuring hydraulic cylinder bore that was, I think, about 4 3/4 of an inch diameter, and making a packing gland and a new piston rod to go inside of it. So the tolerance of a couple thousandths or a thousandth of an inch with that was acceptable. The reason I don't like them, they're sloppy. And, well, errors tend to accumulate, right? I make a measurement error. This is inaccurate. The method I might have used, I might have goofed up. So they start to compound, right? So you always want to give yourself the best opportunity of an outcome by using the best equipment. Take a quick look at the Japanese ones. I mean, there's barely a wiggle in there. And I just believe the better made tool performs better, right? So how do you use these, and are they necessary, and how much do they cost? I did not look up the price of SPI. I wanted something to be less prosumer and more something the average guy and gal in their shop can use and figure out, hey, what's the size of that piston bore? What's the size of that bushing? Hey, what's the bearing? The good thing is, talking about bearings, bearings actually are pretty easy to measure with your calipers, just because they afford very nice smooth surfaces. There's no banged up or rolled over edge here, which you may see on some other things like a soft bronze bushing, may be damaged during this disassembly. You're more likely to get an error measuring something else. This, 17 millimeter bore, you can see how close we can get just with light pressure with the calipers. But again, we're running on a very precision surface, right? OD, not so much of a problem. In general, I wouldn't recommend using calipers for any precision machine work. At home, Saturday afternoon, you're fixing something, yeah, go for it. But give yourself an advantage by even picking up the inexpensive telescopic gauges. $20, crazy. I can't believe how cheap tools are now. I mean, inexpensive. They may be cheap in quality too. That's for the buyer to be aware of. So how do you use them? Let's quickly hop onto this. Okay, well, we know this has a 17 millimeter bore. This is a bearing out of a table saw I'm rebuilding. So it's good to start with a known quantity. you can figure out real fast if you're not measuring correctly. The way these work, you compress them, you turn the base to lock it, you turn to release it, you release that inside the bore when it's at an angle, and then you tighten it, you rotate it around, and we'll demonstrate it, okay? We're in the bore, it's locked, release, tighten it up here, nice and snug, hold the piece, rotate around, past center, that compressed during that operation. Now we should be able to measure it. 17 millimeters, I think it's like 670,000. I should have checked it before this. Anyway, I like to use micrometers, veneer micrometers. I do have a really nice Mitutoyo digital, but for the sake of this, I just figured it's okay to use this. Okay, so you sneak up on it, because you're not going to use this micrometer as a C-clamp. So we're looking at I can just feel it rub past the face of the micrometer. And we're right at, I'll lock it. We're right at 650 is the line there. All the way around would be to 0 would be 25. I apologize, I just realized people may not be able to read the veneer scale. So this is 70. And it looks like we're just shy of meeting the line. So we go over to the 10th scale here. And which line here is falling on the tenths? This is 9/10,000ths of an inch, lines up with a 6. Ignore the 6. We're only reading the scale here. Starts at 0, goes around to 0. Basically 0 through 9. So we have just a 1/10,000th of an inch under 17 millimeters. It works. You can also takes a little bit, make sure this is unlocked, takes a little bit more of a fine touch to use the calipers to do the same thing. But again, we're only reading as much as the graduated digital readout shows. Convert over to inch quickly. We have 669 thousandths, 0/10ths of an inch. For home shop stuff, a lot of general machining, this is plenty accurate for doing this. It's a good method. Telescopic gauges, they're definitely worth having. You can marry up this $20, well, I think I paid 50 or 60 for this back in the early 2000s when I was an apprentice tool maker, which I wound up having to do everything in the shop, not just tool making. Anyway, you can marry up, toss out a $25 bill roughly, something on Amazon, along with your whatever caliper you have, and you probably would be good to go. Maybe be able to do this for gunsmithing, putting the choke on your 12 gauge. You know, that's a big deal for guys who want to measure inside the barrel, need to get in there inch and a half. They whine about the caliper not being able to reach into the depth long enough. Well, here you go, guys. Toss out a $20 bill, maybe practice on a known quantity. You know what this is. It's a bearing. It's precision ground. You don't need to go buy precision ring gauges. You can learn yourself. You can do this yourself. I know you can do it. It's amazing. I'm so amazed at being able just to tell somebody how to do something and watch them turn around and away they go. You can do it. I got confidence in you. You can do it. You can get out there. You can teach yourself to measure things. You know, when I was starting out, I had a bunch of bolts and screws, and I knew the size. I'd written it on with a Sharpie, but I would measure them, and I would look at them, and I could just learn. I would pick something up and go, oh, yeah, that's 7/16 course. And I did that because I worked with people who knew how to do that. And I was like, all right, they're not gods, but somehow they did something where they gave themselves an advantage. They taught themselves. And you can find shortcuts like that. There's absolutely no shame in making notes and following what other people do that is successful, right? All right. One more thing, and we'll be wrapping this up. All right. Here's that one more thing. Small hole gauge, right? Mentioned that at the beginning of the video. Let's go through and use it and see how it functions and mechanically observe how it works. Turning the screw here, I should say the thumb screw here, actuates the screw inside, which basically allows it to open and close. And the way you use it, you're way ahead of me, you already know this, right? The way you use it, though, it does, both this and the telescopic gauges require some hand skill. You have to teach yourself. You have to be sensitive to what's going on. You have to imagine what's going on inside the bore and maybe determine if the hole is out of round. Maybe it has, like, let's say, imagine it's moving really smoothly around in here. And as I pull it out, I can't get it out. I can here, but just for example. Now, if you would have measured that with the calipers would have just gotten high point contact with a burr or a ridge at the top and not given an accurate reading. So it's a little bit dicey using the blades here for ID measurement on everything. You have to take that with a little bit of caution. So here we have just a slight drag. Maybe you can even hear that. Let's pull it out. It's fixed now. It's in tension, so we don't have to worry about it moving on us, as long as we keep our fingers off the thumb screw. So let's knock that a little bit. Come in here. That hole I just measured, I do know it's a clearance hole for a 3/8 bolt, I believe. I disassembled this machine about 9 weeks ago. There's a story there. We'll be working on it shortly here, though. So I'm rotating it as I'm tightening the micrometer, and I'm sneaking up on it. Okay, there we are. I can feel it. Back it off. 411.5 thousandths, and that's measuring that screw hole. The other thing you can do here is also see if the hole is round. So we have it set across this axis. Do we feel the same amount of drag on the other side? Yeah, I do. So we know it's a fairly round hole for all intents and purposes. It is. I hope you enjoyed this. If you have questions or comments, if there's other machinist type tools you're curious about how to use them correctly, ask, bring it up. There's a great community of users and people out there on YouTube with knowledge, and more knowledge than I have probably, and that's great. I mean, that's what we're here for. It's just a terrific platform for sharing know-how and putting it out there. So I really appreciate you taking the time to watch this, and I look forward to seeing you in the next video. Have a great day.